In your notes there was a question about determining the grams of glucose. C6H12O6 to produce a certain concentration and a volume of ethanol, and it was I think 500 mils of 2.5 molar ethanol. So this is our volume, this is our molarity or C concentration. Often we want litres, not mils, so 500 mils is 0.5 litres. So that's our volume, this is our concentration. And from that we can find number of moles. If we remember that formula, concentration also ethanol, C2H5OH. And we can work out the total for these. I think that's 180 grams if you work it out. So concentration equals number of moles divided by volume. And you can remember that because it's moles per litre. This is our number of moles, this is our volume. You can remember concentration equals moles per litre. So 2.5 m equals 2.5 moles per litre. The little minus 1 is the same as putting the litre down the bottom here, up under the moles. So it's 2.5 m moles per litre. Moles per litre. Now we can rearrange this equation here, and we times this side by volume, so we have to do the same over here. And the volumes cancel out, and we get number of moles equals volume times concentration. Now we want to work out this 500 mils or 0.5 litres and 2.5 molar. We need to figure out how many moles of ethanol that is, because they're not telling us, they're only telling the volume and the concentration. So the volume was 0.5 litres times the concentration was 2.5 m equals the number of moles. So 0.5 times 2.5 m is 1.25 moles of ethanol are produced. So we've got to find out how much sugar or how much glucose will produce this much ethanol. So to do that we need to think about our equation for making ethanol from glucose. And so we look at the equation. I'll just move this up a little bit. And the equation is C6H12O6 goes with the yeast and the correct temperature to C2H5OH, our ethanol, plus a gas is produced, CO2 gas. Now if we balance this equation, because we need to balance it before we work out, and we work this is going to be how many moles of that we need. So we balance this out. 6 C's over that side, we've got 3 here, so double this. And then we need more, we need 4 C's there, so we need another 2 C's, and then we look at the rest. 4 oxygens, 2 oxygens, 6, yep, okay, that's balanced. Now, if we look at this, we have 1 mole of glucose gives us 2 moles of ethanol and 2 moles of carbon dioxide. We're not interested in the carbon dioxide at this point. So it's 1 of ethanol, 1 of sugar, 1 of glucose gives 2 of ethanol. If we want 1.25 moles there, how much do we need to start with? Well, if 2 moles is produced from 1, so that's half. So 1.25 moles, we need to halve this to find out what we would start with to get us 1.25 moles. So it's 1 to 2, something to this. So this value here we need to halve, and then we get this value. And half of 1.25 is 0.625. Okay, so this is how many moles we need to produce 1.25 moles. And that's what the question's asking us. 1.25 moles, and we got that from this equation up here. So how much is 0.625 moles of glucose? We need to just work that out. So we'll just move this up a little bit. Now, the number of moles of a substance is number of moles equals the weight that you have in grams divided by the molecular weight of the substance. And the molecular weight of glucose is 180 grams. So that's the number down the bottom here. The number of moles is 0.625 equals the weight that we need divided by 180 grams. And we times this side by 180, we can cancel those. So we have to do the same over here. So the weight that gives us 0.625 moles equals 180 times 0.625. Okay, this was the molecular weight. This was the number of moles. And this is the weight we want. So the weight we want in grams. And that equals 112.5 grams. And that's the ethanol, the glucose needed to make .5 litres of 2.5 molar ethanol. Now if you look at the question up here, most of these are in three significant figures, or so we can round this off. We just put 3 grams. Make sure you put the units, grams, whenever you're trying to find out the amount of a substance. Okay.